All right. All right. So let's get things going. Again, I'm Charles Lively, and these slides were taking originally adapted from Nick Tyler, who is also in our programming environments and models group as well. So here at Nurse, we have various groups that contribute and help keep our facilities active and running. So we appreciate everyone's contributions and helping contribute to new user training. And so for today, what we're going to do is we're going to talk about running jobs. So you've been introduced to the nurse ecosystem. You hopefully have access to your account in Iris, and now you have a project, you got an allocation. Now it's time to get some work done. And so if you're new to HPC, you might not be familiar with what a job is or how it can help you or how you need to use it to run your code. So that's what we're going to go through here at Nurse, teaching you how to get your first HPC jobs going, as well as understanding some more advanced environments that and tools that you can utilize to help make your scientific endeavors more productive as well. Talk about different tools, workflows, working in containers, as well as touching on the docs and JavaScript generator that you can use as well. All right, so now let's just talk about some of the basics of job submissions. And so, what exactly is a job? And, when you think about a job, it's just basically what we say when you're using a measurement of computation. So you submit a simulation, then that is going to be your job. It's basically the encapsulate all of the components you need to execute your application, the number of GPUs that you'll need to use, the source code or the object file that's going to be executed. And so we manage our jobs using a job scheduler, and it's just like that. It's a software tool that you use to access the resources you need for executing your job. And the way that you get a job deployed is through a job script. So you have the script is basically going to lay out all of the resources that you are requiring for, your job to execute. If you are making a dish, or you would think of the job script as kind of like the recipe with all of the ingredients and things that you need. And then you can have different types of jobs, such as a interactive job or a batch job. And an interactive job basically means that you are getting those resources allocated in real time for you to use interactively. So you can, think about it as doing science interactively versus a batch job is you submit it and you wait for it to finally execute. And so, how are jobs managed? Probably one of the most important things that you'll need to understand is using our job workloads manager, which is called Slurm. And so Slurm is a workload manager. It's an open source job scheduling tool. If you are not new to HPC, you might have used Slurm or some other job scheduler as it's open source, but it's adaptable for the systems that it's ran on. So basically with Slurm, it takes care of three key responsibilities, and that's, allocating those resources. It executes and it monitors all of your jobs, and it also manages the priority of your job. And we'll get more into priorities and queues, the queue status later as well. So if you're familiar with Slurm, or you've used it on another HPC system, it's just important to understand that they're configured differently. So maybe one way that you use Slurm on another system, it won't necessarily, you might have to make a little adaptation to use it on Perlmutter for your scripts and whatnot. All right. So what do you do to get your job going? Well, once you connect to Perlmutter, as Lippy explained yesterday, when you connect, you're on a login node. So even if you log in with Jupyter or something, you're going to be on the login nodes. And login nodes are meant to be just quick resources used for quick computation, and they're not meant to be used for large computing tasks. And, again, they're all shared by users as well. And we only have about 40 login nodes. So we recommend using the login nodes for just quick debugging and quick little, you know, trial runs, but nothing too big. So where exactly does your computation go? And with that, it's going to go on a compute node. And so with Perlmutter, we have over 4,864 compute nodes, and and over 1,700, almost 1,800 are GPU nodes, and over 3,000 are CPU nodes. So when you do submit a job, it is going to go to one of those computation nodes, depending on how you've set things up. And so again, there are different ways to access a compute node. You can access it interactively, or you can access it through a batch submission. And with the interactive submission, it's basically you're accessing it directly, and you can access it via command line, or you can do it through a Jupyter notebook. If you've done a lot of work in Python and worked in Jupyter notebooks a lot, you can, interactively use a notebook and do different simulations and, graphs and make use of the different libraries right interactively live. So that's what we mean when we say an interactive job. And then you can also do a batch job. And typically, when you think about a batch job, it's going to be those larger scale job across multiple nodes, could be even hundreds of nodes that are going to require um, several hours or even days to compute. And so with a batch job, it's just something like, okay, this is going to take some time. So you send it off and then you just wait for your alert of when it's completed. Okay. So in order for you to work on Slurm, it's a few different things that you need to know. There are a few different ways in which you can specify the needs of your job in Slurm. And so there are different flags that we have that you can utilize. And so you can use the short form or the long form. You're going to need to denote the number of nodes. That's going to be the number of nodes that you're requesting. You're going to need to know the number of tasks, basically the number of whether it's going to be, total MPI ranks that you're going to be needing to use. You'll need to denote the account that you'll have and your nurse project by default. You will need to specify the queue quality of service that you're going to need to utilize for submitting. And the quality of service is basically part of what determines the priority of your job. Then you'll need to specify any constraints, whether you're going to be using CPU only resources or GPU enabled. And then most importantly is the wall time. So these are all different flags and components that you need to specify that will be used to determine your priority in the queue. And the thing about doing that is that there's no no set way of saying that, oh, I'll have the highest priority. It just depends on what everyone else in the queue has, what they've entered the priority. So typically, um, of course, the quicker, shorter jobs are likely to have to run better if they're able to get those resources quicker. So it's important to understand and specify the uh, the right parameters for your job to make sure it gets executed as quick as you need it to be. Okay. And so how do you get started with an interactive job from Slurm? And so with interactive jobs, it's easy for you to get started. You can use a Slurm allocation command, salloc, and basically this is going to provide you with the allocation right there on Perlmutter. And so let's say you need to do a specific allocation for a specific number of resources. With the salloc command, we can include some of those Slurm flags that we previously noticed, like the account to use. Here I've specified it, the number of nodes, just one node. The wall clock time is 10 minutes, and the constraint is GPU. And so when you hit enter, you enter this information for your command, and Slurm will give you an update. It'll tell you that your pending job allocation, and it'll give you that ID. And then once that ID is queued and waiting for resources, it gives you another update. And once those resources have been allocated, meaning if you're in a restaurant, we got a table for you. Now the hostess comes and they walk you to your table. They're waiting for it to be set up. The resources are configured. And then once your table is ready, your nodes are ready, you're ready to eat, your job is ready to process. Yeah, that's a quick little kind of easy analogy to understand the process for when you submit a job. Did we have any questions or thoughts thus far? We got a show of hands of how many people are completely new to using Slurm, or even if you want to enter it into the chat really quickly. Do we have anyone that's completely new to using Slurm? You want to just say, okay, oh, good, Elizabeth. I'm glad it's helpful. Anyone else? Do we have anyone with maybe not experience with Slurm, but experience using another um, job scheduler or job manager like AIX or anything else, depending on the type of system? Okay, Stephen hasn't used Interactive yet. Anybody else? Okay, well,
The
hopefully,
question, if you want to clarify, since
okay.
Charles mentioned that direct access to compute node and command line access, both interactive. What's the difference? How would you access it other than through command line or Jupyter?
Um, so command line would just be through terminal. Jupyter, you could use it, both would be interactive, but with Jupyter, you could access it through our Jupyter portal on Nurse. And actually, after this talk, Lippy is going to give an overview of Jupyter. And you just would simply indicate that you're going to do it on the login node, and you can do it interactively by allocating if you need to do more resources. But whether it's command line or versus Jupyter, either one of those could be interactive. Hopefully that clarified. Oh, so let's go back. Are you talking about this slide, Richard? So you would need to explicitly note whether you wanted to do a shared or um, exclusive. So by default, you're sharing. Does that make sense? And we'll get more in details into some of the different flags and some of our later examples too. Okay. Does that make sense, Richard? Or Or Stephen, I'm sorry. Okay, no worries. Okay, and so here is just kind of going through, breaking down what some of those different flags mean and what we use them. So again, we give it the number of compute nodes to use with salloc command. Then we want to make a note of our account that it's going to be charging to. Then we have allocated the number of nodes that we want. And remember, you can always use either the short form, just the letter, or you can use the long form, which will typically spell out what that flag means. Then we also denote that we're going to use the time. In this case, we have a wall clock time of 10 minutes. And again, specifying that constraint that is going to be using GPU resources for the type of node. And so when do you want to use an interactive job? So again, you want to use it to test and debug code. Also, it can be good for profiling as well. And so with the noting, the interactive, for the interactive quality of service, you'll use the flag interactive or QoS equals interactive. And there are specific limits that are denoted. You have 1 to 4 nodes that can be used, and you have a max wall clock time of 4 hours. And you can denote whether you're going to use it as a shared resource or whether it's going to be uh, where it's going to be a shared resource. If it's shared, then there are different constraints. You're going to have half of the node max that you can use and 48 hours max wall clock time. So these are some of the different constraints to consider when using a interactive job. Okay, and so, whoop, sorry about that. And so how do you get to an interactive job from Slurm? Here, there are different options that you can get to a compute node. And again, after this, Lippy is going to present on Jupyter, but a quick and easy way is through Jupyter Hub. It's just jupyter.nurse.gov. And you can easily access a login node, a shared GPU node, exclusive CPU node, exclusive GPU, or you can do a more custom configurable script for multiple nodes to access. And again, this is just accessing it quick and easy through Jupyter Hub, which you'll have a detailed presentation on by Lippy next. So, we talked about some of those limitations that are in place for interactive jobs. So what are some things what do you do if you need more than, 4 nodes and 4 hours of wall clock time? Well, that's when you do one of the batch job submissions. And again, you think of a batch job script as being something requiring that at the extreme end could require all 3,000 nodes that are available on Perlmutter. But it allows for you to schedule your job, lay out those detailed requirements, and then the Slurm job scheduler will assign priority in denoting when your job will get scheduled. So if your job requires a lot of time to execute, then you're going to need and expect it to be in the queue waiting for more time. And if your job requires a lot more nodes, then that's going to also be another factor that will affect the priority of it. So typically, the more time and the more job, the more number of nodes that you have, that's going to um, have your job waiting in the queue longer. But once you've denoted your requirements, you just put it in a job script, which we're going to walk through again. And then you just do a batch submission. And to do that with Slurm, you just do an S batch and then the name of the script. And then you'll get a notification that your job script has been submitted and it'll give you that ID. Okay. And so again, what does your job script look like? So again, this is what a job script looks like. And so it's the same similar components as if you were to use the salloc command, but instead now you've placed them within a script file that's denoted, and that each line with each flag, you just make sure you have the sbatch flag. So this basically allows for you to make a denote that you're doing a Slurm batch allocation. And so Slurm is going to read each option appropriately in the same manner as we previously denoted. In this case, we have additional flags. We can specify a more specific job name for a job. And so in this case, we've named the job science, and then it'll also have a job ID as well. All right. And so another thing that you want to denote is that the srun command is what is going to execute your actual application and with the number of nodes as well as any specifications of any type of CPU binding that you want to do. So we'll get into it. And another thing that is helpful about um, well, we'll get into the job script generator later. That's a useful tool for helping if you don't know specifically how you should configure your script. Our script generator will ask you a few questions and then help you generate it automatically. So Slurm will use the slurm in nodes command to get the number of requested nodes as well. And we already said srun is the command to run the parallel job instead of making use of MPI run. So if you've worked on another system, you've probably and did parallel runs with MPI, and then you probably have used MPI run to execute your previous job runs. All right. Okay. And so another important thing to make sure you consider is the different type of queue options that are available. And so we have our debug queue that can denote what we're debugging a queue. And we have other different queues as well. And each queue and its constraints are listed on our nurse webpage a nice laid out table. But at a high level, these are some considerations and restrictions for each of the qualities of service that you can use. If you do a debug, it's 1 to 8 nodes, 30-minute max wall time. It's good for testing your script and scaling before running large jobs. And then you also have regular and shared. And this is where most of our users, these are the queues that most of our users will go to, regular or shared. You have more 24 hours max wall clock time and allows for a 5,000 max job submissions. And so those queues are just denoted with the keyword regular and shared. And again, shared is half a node max per job. So different options are available for helping you determine the priority that you want to use. And then you also have different override options that you can use for debugging as well. And so again, you can use the debug queue, you can use different scale testing as well for different parameters. So if you want to scale and see how your application runs from a smaller number of cores to a larger number, SBatch is good for different quick, easy submission and testings in that way. And that way you can enter multiple, you can execute and submit multiple scripts to execute as well. Okay, some considerations to take into account when you're using shared queues as well is that you can do multiple jobs you can do multiple jobs for different uses on a single node, and so shared jobs are going to only charge a fraction of the node resources that you use. So you can use those to run small parallel jobs and really quick and simple typical really simple, quick, and easy jobs, as well as serial jobs too. And so this is just giving you an example of the different flags and constraints that you want to use when you're doing a shared job, and for some of the different constraints. And so this one is an example of a MPI job that's just going to use two MPI tasks using srun, then just a demonstration of using a simple serial job that just is executing that a dot out. Right. Did we have any other questions before we move into the second half? How are we doing on time? Should be good. Are we good on questions?
We are good on questions. Yes. Thanks,
Okay.
Charles.
All right. Awesome. All right. And so on Perlmutter, it's also important to consider that there are um, different hierarchies to the architecture that we use. And so for our CPU compute node, we have each node will have two sockets and four NUMA domain sockets per node. So what you see here are different NUMA sockets and cores that are available. And each node is going to have 8 sockets available. And basically, what that breaks down into is that we'll have 128 physical cores that users are able to access, as well as 256 different logical cores that you can access. Um, and if that's a little confusing for you, because if you're new to HPC, you can think about it logically as understanding whether you're going to be doing MPI only runs versus MPI with OpenMP threads for multi-threading too, as well as other using what we'll get into the GPU cores. So that provides you with the number of computational cores that you're able to access on a per node basis. And so, one of the biggest things about making proper use of large scale HPC systems is making sure that you have a correct and logical understanding of process, thread, and memory affinity, because each component is critical for getting optimal performance and also making sure that you don't end up wasting a run because you haven't properly assigned the different processes and understood the memory maybe requirements. So when you think about process affinity, that's going to be binding those specific MPI tasks to specific CPU cores. And then you can do thread affinity. Affinity can be used to bind different threads to CPUs that are allocated over MPI processes. And then you can also do memory affinity for providing or allocating memory more specific in those specific NUMA domains. Um, Different ways in which you can do that, binding the cores using the different CPU bind options is available. And you can do it. Multiple processes can land on the same core when cores are idle. So um, having a good understanding of how you correctly configure and allocate the processes is important to ensuring you don't get wonky or weird results, which is normally what happens is that users will come here and they have a script that they used on another system, they run it, it works, it does not give them any errors, but the results come out wonky because they haven't made those proper adjustments for the new system. So that's another important thing that you want to consider. Okay. And so understanding the differences between, our CPU and GPU um, compute nodes and their differences in processor affinity as well. So consider again, we said on Perlmutter, we have 128 Perlmutter CPU, we have 128 physical cores because they don't have the GPUs available. And so that means logical CPUs per physical core are going to be two. And then how many logical CPUs per node or 256. And NUMA domains, we have eight. Okay. And so what this means is that we essentially can have on our GPU version, now that we have GPUs included, that essentially gets cut in half. Now we only have 64 cores, physical cores, CPU cores on our GPU node. We have two CPUs per physical core, and now 128 logical CPUs per node. And so this changes our neural domains in half from eight to four. And so what this means is that we have different constraints that can be used for a CPU node versus a CPU and GPU node. And so with the CPU node, your SRun constraints and basically the number of MPI tasks per node is going to be uh, at the most 128 on CPU versus 64 on a GPU enabled node. So those are another logical considerations to take into account versus using a CPU versus GPU nodes. And a lot of times your application might not even be configured to run on GPUs just yet. All right. And so here's some other example options for MPI codes, applying the number of nodes that you're going to use, denoting the time, and then what you have specified in your SBatch or in your SRun command here, you'll have the number of cores that you're going to need to use. So how many cores are we going to be binding? And we'll have the number of cores that we're binding to, as well as the number of nodes in this case, or number of processes in this case, to execute it and run it. So when we use a CPU binding with cores, we want to make sure the number of MPI tasks are less than or equal to the number of cores available. If we're going to use the CPU binding with threads, then we want the number of MPI tasks to be greater than the number of cores. And so that's when the C value comes into play. And plugging it in for our CPU option here, we get our TPN is going to be 16. So, and if you want, make sure you remember TPN is just our number of MPI tasks per node. So, and again, this is helpful for using the job script as well. If you're going to use OpenMP enabled options as well, then you'll need to export the number of OpenMP threads, their logical, the placement that you want to use, and any type of binding that you want to use as well. And so with OpenMP, it's configured through environmental variables and other different configurations that can be used. And a lot of our libraries can make use of OpenMP by default. A lot of the scientific libraries that's most used for benchmarking and whatnot. And again, we also have different examples for showing you how to properly execute hybrid applications if you're going to use MPI and OpenMP hybrid code to use. And you have different constraints that you need to consider in that the number of cores per task should be greater than or equal to the number of OpenMP threads. And so a common problem is making sure you have enough CPUs to use with the OpenMP threads efficiently as well. And we have different example scripts to show you in our nurse documentation different ways that you can configure your scripts. And so different options to consider for GPU-enabled codes is that with the GPU, you can specify the number of GPUs per task using the GPUs per task flag. And then you can also specify more specific GPU binding as well. And so again, with this will, we are C value changes using for GPUs. So now our MPI task per node would be 4 here. So those are different constraints to consider if you're going to use a GPU enabled that also makes use of OpenMP and other parallel libraries as well. Right. Okay, we're in the final section. We're doing on time. Good. All right. Do we have a break after I'm done, Lippy?
We actually technically don't, but we could take one because we're running quite ahead of schedule. Um, one sec, let me pull up. Yeah, yeah, if you want, once you finish up, we can take a quick break.
So I will go through these next two. I think it's two more sections on workflows, and then we can take a break before we go to Jupyter then. Okay, so we've gone through the basics of what is a job, how to submit it, whether it's interactively through batch scripts or whatnot, and some of the different types of jobs that you can do. But of course, we never really have just one type of job that we have to do. Even when we have one job, within our job, we have multiple jobs that we have to do. And so if you have multiple things that you need to do, there are different tools and things that are available to help you figure out the best way to execute multiple jobs, either sequentially or simultaneously. You can do different bundling of jobs with Slurm. You can use a job array to execute the same job with different tasks. And then you also have different workflow tools that you can utilize for executing multiple different tasks. And there are also other more complex workflow frameworks that you can utilize. So here we'll just go through an overview of some of those different tools and techniques that you can use. This is just meant to provide you with a high-level overview. We do have an entire group that focuses on understanding efficient scientific workflows. So again, if this is something you're strongly interested in, we would recommend you booking just a appointment to talk with a consultant that can help you get your science workflow set up to perform more efficiently. And so you can bundle your jobs, bundling work into one job. And so basically, when you bundle it, you can think of it as just you're maxing out what the total of those of different jobs will be and submitting it in one batch script versus doing different scripts and waiting for results. And so when you bundle jobs sequentially, they'll run sequentially, and you only have to wait for the scheduler once. So they'll reuse the same allocated nodes for the different steps of your workflow. And so this is just a simple way in which if you have different executables you need to run, different simulations or experiments, that you can bundle them together and execute them appropriately based off of the constraints that you need. You'll just want to denote whatever the job that has the maximum constraints, just you'll want to use that as the limiting factor. So that's one way to do to bundle multiple jobs together. You can also add for a specificity to have it to wait once for that resource. And basically, this is going to run the same program with different inputs. And so this is just going to run it and then wait for all of those to run. So this is going to give you just different inputs that are going to be used for each run. And so another thing that you could make use of is what's called Slurm arrays. And so with Slurm job arrays, you can use those to handle multiple um, jobs, and Slurm is going to handle them independently. So you don't have to worry about um, if one of them fails, then your entire runs are not affected. So that's good for if you're doing needing to get data on different inputs that require large, statistics, or if it's going to do a specific type of parameter sweep over various input files. And so we have different examples and documentation to show you how to create and set up a job array for if you're going to want to make use of Slurm job arrays as well. And so another way to do this is using a new parallel option. And so with this, it basically manages the task inside of the allocation for you. The caveats is that or the strengths are that it's good for many small tasks, and I guess at a micro level runs faster than S runs. Um, and it allows for reuse of your allocation for all of the tasks. And for each task as it finishes, it executes the next one, which makes it more efficient for allocation reuse as well. So that is another option that you have to utilize on Perlmutter, and we have more examples and documentations on how to set that up as well. And for any of these options, if you do have problems, then you can also submit a ticket or set up again, a consulting call as well. And then different options that are available for more complex workflows include using different workflow management systems, parcel function X, even Globus that Lippy presented on yesterday is a good workforce data management resource to use. And then there are other different frameworks that can be used. And the thing to keep in mind is it's kind of like taking a black box and you're writing code to define your workflow. A lot of time it's written in Python, and then you are just configuring it to handle different aspects of your scientific workflows. So moving forward for Nurse 10, which will be our next system that we haven't officially named, but that will be coming soon. A big focus is on across several DOE labs and facilities is um, having an integrated workflow for researchers to work together as well. All right, getting towards the end. So next up, we briefly talked a little bit about containers yesterday when we were talking about Python. Um, and so another wonderful and great way to have stronger control of your programming and domain environment is by making use of containers between systems. And so it helps to make your software portable between various systems for reuse. You can make use of different type of containers like a shifter and Podman here at Nurse as well. And you can use it and build images on the login node. Currently, we don't support Singularity and Aptainer on Perlmutter. Yes. So what are some different ways that we can use a container? And well, if you don't know what a container is, let's start there. So a container is basically a very simple and portable way for you to build and pack all of your software that makes it easy and portable to ship between different systems. And so you can easily build it on your personal computer or another system. And then using Docker, you're able to basically store it in management and have it shared. So if you build it with Docker, you can push it to Docker, and then it can be ran and executed via Docker and any other Docker container management utility. Okay. And so if you want to use containers at Docker containers at Nurse, Nurse has a registry for where you are to build and ship them. And so you just do registry.nurse.gov. And then we have a Docker, the command is just your Docker build -t. And then you have specific flags that you will put for the project and again, the name and version and whatnot. Once it's shipped, once it's built, you can ship it to Docker and then have it be pushed as well appropriately. And then once it's shipped, you can run it on Shifter or Podman HPC on or Podman on Perlmutter as well. We do have a useful container training that you can take that is on a spin that goes over all of these different technologies. And so that is, if you're not familiar, we definitely recommend that you sign up and take the spin workshop. Again, we have documentation that's available as well. And so how do you run a Shifter container? So if you want to pull your image from Shifter, all you need to do is pull that from the registry using pull the registry and the image and the tag. And so the SBatch flag that you would just use is for the image flag, and you would just assign that value that you're pulling, and then in your srun command, you'll just make use that you're using Shifter for it. So that's a quick and easy way to run a Shifter container on Perlmutter. And so, of course, there are always going to be extra options that you can use for running your Shifter image as well. So here are a few of those different object options. You can specify any type of modules that you want to use, the volume location, etc. for it as well. And more details about some of these different flags and options, of course, are available on our Nurse documentation. And a similar approach to running a container using Podman. Again, you'll pull your image, of course, and then you just specify that image and tag as well. And again, you'll specify Podman HPC run and then that location for it. And so to pull or build a Podman container, you can do it easily on the login nodes and then migrate it to Scratch. So you can just do your Podman HPC build command, and then the image and the tag that you're building. And then you can use the migrate command to migrate it. And different options that you can use for Docker and Podman again, or specifying that volume on your Scratch directory as well. And then you have other extra options again for different modules that you can want to use if you're going to use MPI or GPU specifics, or if you need CUDA enabled MPI as well. Okay, so now that we have talked about all of the different ways in which we can submit a job, prioritize a job, workflow a job, how do we monitor the jobs? I promise I'm almost done. So if we want to monitor our jobs and see how they're working, we would need to just make use of the Slurm queue. And so it's basically the SQ command basically denotes different jobs that have ran on, and executed for you within the Slurm queue. And so different ways to access that. You can access it with just using SQS. And basically what this will do is it'll give you a overview of your most recent running jobs as well, and different flags that it are, different shortcuts that it has for different outputs. You can get the current running state of the job, whether it's pending, and then the time that it is taken, or the time limit as well. So that's a quick and easy way to get some of the information about the jobs that you have processing or waiting to execute or have completed. If you need to cancel a job, that is very simple and easy for you to do as well. So you can just use the scancel command. And here we have just a breakdown of a few different ways. I've submitted a job script. I've gotten the job script confirmation that it has been submitted. I've done SQS to pull up recent jobs and see how they are going. And then I decide to do an scancel on the job that we had just submitted. And in order to do it, all you do is enter scancel and then that job ID right here. And then you'll run SQS again, and it'll show that it has been canceled. And so if you want to look at all of your completed jobs, the saccount command provides for Slurm accounting for data for all jobs and job steps. And so by default, it'll show any jobs completed in that last day for you. And all you have to do is enter saccount, and it'll show you those most recent jobs. And so different ways to look at completed jobs. You can do saccount, and then the job. If you have the job ID, you can do saccount. And if you have other constraints like the name of it, and then a constraint on whether it was a specific GPU or CPU, you can do that. And then you can also do it based off of the current state if you want to pull all jobs that are currently running. So different ways and flags that you can utilize to denote the different job states of any of your jobs that are currently running or being completed. All right, and so some best practices to consider with job scheduling. You want to consider, of course, all of the factors come into play. Make sure you use a good priority value for those considerations. Only 2 jobs per those groupings can gain priority at a time. So this allows for more jobs to run, and only 2 within that you've submitted will age. Our main SARM scheduler uses a priority list, and so it schedules a few days in the future. And we also have our backfill scheduler that puts shorter jobs in holes, and that helps to prioritize that Perlmutter is just being utilized properly and efficiently. So other tips, if you do one job with a large allocation, this is going to give you a per node priority aging, and that's going to be at the highest. And so that can best be scheduled first. If you have shorter time jobs, those can be easier to schedule for backfill. And you can also make use of a workflow manager. A lot of times it's choosing the right time for Slurm to use. And so it's always good to go and get an active look at how the queue is looking. Because if you can strategically plan when you are submitting your jobs, then you can get your results more strategically and quicker as well. Okay, and again, we have our job script generator that you can easily make use of, and it'll ask you a couple of simple questions, and it'll provide you with a example script to use if you're a little bit confused on any of these different settings that you need to set or flags for your script to execute. All right, what did we cover? It was a lot. We hopefully everyone knows what a job is. If you don't know what a job is, I have completely failed, but I hope I haven't failed. We talked about how to run your code as a job, running a job in a container, workflows, and a brief overview of our docs and script generator. Um, yeah, any questions now?
I think we've handled the questions in the Q&A so far. Yeah, in general, if you have a job that needs to run for more than 48 hours, you might have to make a reservation. Um, but there may also be a way, to this person, the person who left the comment in the Q&A, I was just thinking about this. It's possible that the job took longer if you were on a smaller cluster and you didn't have access to as many nodes, maybe. So it's also possible that your job may not take as long if you are able to use more nodes. Obviously, that would depend on your configuration for your job, if it's able to parallelize or whatever, but that's something that
Mhm.
is always worth considering. Like, you use more of the system.
Yeah, it's really hard to,
Yeah, go
yeah,
ahead.
because it's so many different factors because you could consider, maybe even if you had to execute on just 10 nodes and you probably got priority one time versus another because there were maybe just 10 to 12 nodes available for free and you were the only job that needed that 10 nodes. And so you just automatically got it. So it's really just a logistical kind of thing and it can vary because it's also based off of what other jobs have been in the queue and what resources they need. So it's really almost you think about it if you go to a busy restaurant and you know you have a party of six people versus a party of two or three people, and the six people might have to wait an hour, but the two or three people they can easily find a table for them.
Yeah.
It's very similar to that.
That's a nice analogy, Charles. I love it. I'm gonna keep that in
Thank
my
you. I need
analogy
to
bank.
copyright that now.
No, that's really good.
Just add you can try small jobs first, debugging, and then when your
Yeah.
jobs you want a long production jobs, and you still have an issue, send us a ticket. We can help you individually.
Yeah.
Yeah, in general, I've found this to be the case for a lot of the tickets I've looked at where people are just launching their full job, and then they have trouble. It's better to do a smaller version of if you can to find all the kinks, and then you can also um, figure out a good way to use as many nodes as you can once you're ready for your like production runs. So there's ways of not sitting and waiting for your job to run while you're still in the process of building your script or whatever. So you're not waiting for the queue. The queue on Perlmutter, I mean, it definitely varies probably by the time of year, depending on. So, for example, there's this award called the Gordon Bell. And so there's usually Gordon Bell season, which is like the month or so right before the application is due. The machine is just packed with these jobs, GPU jobs, because people are preparing their submissions for that. And then there's parts of the year where it can be a little bit slower. But I think on average our queue can be a couple days long, like a couple days of backlog, all the way to probably a week or more. So you should expect that your job may wait a little bit. One thing we do also have, the way that Slurm works is that it has this thing called a backfill scheduler. So what it does is every once in a while it goes through, I mean, the once in a while is about like every minute. It goes through and it says, oh, I'm going to see because maybe a job failed, maybe a really big job failed. And now it's like, okay, now I can shove in all these other jobs. So on average, your job will wait quite a while, but it's possible it'll sneak in because the backfill scheduler will find a place to kind of shove it in. So that's part of the problem of us trying to help you predict how long your job will wait in the queue. This is like $1 million project, a $1 billion project, because it's kind of stochastic. On average, your job will wait, but then sometimes it will just start suddenly because it was able to slip in. So it's kind of binary in that way. But anyway, so there, there might be ways to like game the schedule a little bit, but overall, that's probably not going to end up happening. You're just going to kind of have to be patient.
Yeah. If you can figure it out, though, you might want to copyright patent that.
Yeah, publish that paper. Okay, cool.
Oh,
So we're like definitely on schedule slash a little bit ahead.
okay, good.
Why don't we give
Yeah.
everybody so we have what we have left for you now is a Jupyter. I'm actually going to do kind of a walkthrough. A lot of the slides that we have on Jupyter are kind of just like copy and paste from the documentation. So I don't want to just, read documentation to you, but I want to show you what it looks like and then show you where in the documentation you're going to find the information you need if you need to do something a little fancier. So that will probably take us about 10 to 15 minutes. And then we have a really good quiz for you. The quiz is a little bit more serious today. Like yesterday, I had a lot more funny questions. Today's a little bit more, test what you've picked up today. And then we also have a Canvas walkthrough that Charles is going to do. This is our new method for doing um, training. We'd like to incorporate this learning management system to make the whole process of doing these trainings a little bit smoother for everybody. So it'll make ideally like, where's the content? Where are the slides? Like it'll be in like one kind of central place. So we'd like to show that to you all. You are the first nurse users to see that. This is brand spanking new. No one else has, besides a couple staff, have seen this. So that's we have about maybe another 45 minutes to an hour of content left for you guys. So why don't we take let's just do like a 5 minute break. Is everyone okay with that? You can give me a thumbs up. Five
Maybe
minute break.
10.
10 minute break. Okay, Charles wants
Yeah.
to do 10 minute. Okay, 10 minute break. I'm gonna put up on the screen my clock, so we'll be back at 10:40 for those of you who are on the West Coast. It is currently 10:30 here, so we'll be back at 10:40 and then we'll finish up